Hello everyone, it's Peter here, Piotr Fisner. How are you doing, guys? Hello. So today's episode is about that subwoofer, which is a Cube 1 or Cube I, something like that. It's something different, so I wanted to show you. I've instantly regretted when I've unscrewed the box from the main electronics, because the smell I felt, it was just tragic. Here, no, here, the blue. Okay, this capacitor. I'll light up the torch. You can see that this blue is black on one side, and it's so stinky here from burned electronics. Really, I instantly regretted when I've opened it. Let me go back to this. I've got two pictures. Okay, you can see how filthy it is, and on the white side, on the second side, yes, here you had it white. So I need to remove this capacitor to check if anything. So that's how it's looking more. Yes. So what it is that if we see such thing, yes, if we see such thing, then we instantly know that we need to remove this component, and it's glued here as well. This looking like it's a high voltage capacitor, as the marking is C9, yes. So yeah, let me remove it and let's check if there's any short. Okay, because if there's any short, we shouldn't we shouldn't have any power. Yes. So to make it securely, I need to put this on the side and sniff more of this nastiness. Hopefully it won't fall down, because it's like a bit not stable. So I need to use a knife, cut it. It will take me some time. I'll do it off cam. Remove it. Removal will be quick because I've got a soldering iron here in hand. But I'll remove it, and then we can check what else we can diagnose quickly on this board. Yes, and that's a power supply. That's nice, because we've got few boards here actually. This is split into the connectors. That's a control board here. So this board is a control board. This looking like only an amp, just an amp, nothing else. Yeah, because here is a connector for the speakers. So this is an amp board, this is a control board, yes, and this is a power supply. So power section is if we can check how many volts do we need to supply for the control board and for the amp board. Maybe we could replace it with some other, power supply, if we can't fix this power supply, or it's not worth to fix this power supply. Yes, so be right back. Okay, I removed that, and we've got some crunchiness here. But let me switch to the microscope, and I'll show you what we have here. Yes. So let's give us some light. Okay, it's bad, but you can see that this crunchiness is okay. Here it's just burned. I'll switch off the light, or we can maybe angle it. You can see that it's 250 volts here, 250 V volts, and it's 1.0 K. Okay, I'll check. 1.0 K might be 1.1 microfarad, but let's check. Okay, so I couldn't find it on eBay, so I'll change to the Bard. To Bard. So I've asked Bard what capacitance has capacitor 1.0 K 250 volts. Yes, so the capacitor with marking 1.0 K has 2.2 microfarad. Yes, so that's what we need. Kilo, it's K for kilo, so 1 K is equal to 1000. So that's the first pair of marking. 1.0 is the capacitance value. In this case, K stands for kilo, which means 1000. So 1K is equal to 1000. The second part is 2 volts. Therefore, a capacitor with a marking of 1.0, 250 volts, has a capacitor of 2.2 microfarads. Well, I can say that when I've typed it, I couldn't find, yes, I couldn't find it, because it's a power section. It's not a decoupling capacitor. It's not something, you know, really in audio. I would say that even if we put 2.2 microfarads and it won't be, you know, such great match, it still should be okay. So we can order something, but that's from China. I've got 0.1 micro of them. I thought it would be the same, but unfortunately I don't see, so I will have to Google it. I will have to find it. So let's switch back to the webcam. I can maybe look in some power supplies. That would be probably possible to find it. Only let me clean this one because I can't stand it. Okay, so how I'm approaching them, yes? Well, first foremost is I like to check if there's any short on the inlet side, yes? So that's the side here. I will attach my meter in the diode mode, okay? And I'll check if there's no beep, okay? Usually there's no beep, yes? So now that goes through here. That's a ground, and blue and brown. Now it's on. Okay, good. So now, oh well, that's good, and it's growing, so that means the power is coming in. So now what I like to check is, yes, if on those two pins where the capacitor was, so that's this pin and this pin. No, we don't have a short as well. Okay, so where the blown capacitor was, there's no short. That's nice. So now we've got another capacitor here, electrolytic capacitor. We should check with polarity. So mine is on the belt, and then this. Okay, so it's okay. And now we can switch to the capacitance. Depend on the capacity, it will show or it won't show. It will just, okay, microfarads, 202, 209, 211, 213, 213, 215. And it doesn't want to grow rapidly. So 220, which depends on the tolerance, will be okay. Now there is another capacitor, and as well the okay, the minus is on the same side. Weird, but okay. $206 and will grow as well. My probe slipped. Okay, 209. Okay, so it is growing. It's 9.9, 10.1. Yeah, it's steadily growing, so it's fine. So I don't see an issue here apart from that capacitor. Now that capacitor is in line, so it's looking like it's some, oh no, it's going for this resistor or for that filter. Okay, so it won't work, and we have to find the capacitor. In that case, I need to finish it. I don't see further shorts because usually on those main components we see the short. When I've got a bridge rectifier, or here as well, I like to check on the bridge rectifier as well, because although on the AC side might not be any short, which is the inside usually pins, so these, yes, oh, nothing, no beep, yes, and we should have, so it's no beep, because you've got two inner one and two outer one. Oh, okay, and it's growing, that's fine. And it's growing as well. So you see, so in this case, it's safe to plug it in to power, yes? But, there is but. I still need to look for that capacitor, and when I will switch it on, I want to switch it through my this. Yes. Why? Through in series with a bulb? Because if there's any short which I haven't noticed with my meter and with my readings, then it's safe. And now just to show you, it shouldn't be any power. I need a kettle wire, and I'll be right back. Okay, I didn't check the fuse still, so it doesn't make sense. I've prepared everything. I just realized that I haven't checked the fuse, which doesn't make any sense, because how this would work if there's no fuse, yes? So before me connecting to the mains, I'll put mains here, okay? We need to check the fuse, because I would say that if that capacitor had blown, then the fuse should probably blow as well. So let me get this one first on one side, and now let's get, where's the plus, or the, yeah, that's the positive, that's the negative. It is as well, okay. So the fuse didn't blow in that case. I don't see a fuse here anywhere. So okay, let it be. I don't believe it will switch on. It shouldn't switch on. Why it should? So this one first. I press the power on button on this one, and now we can. Now if something will blow, I'll be scared off, so you will have some fun. If nothing, yeah, shouldn't be. Why? Because that capacitor is not, let's get probes, let us measure that. So it's a voltage, but that's DC. I would expect over there to be AC to be true. Can't touch here anything, you know, I don't want to be electrocuted. 0. .8 volts, which is big nothing. We've got a capacitor, 166 volts. Okay, there is a hope. So only we can see that it comes to the transformer almost, because the bridge rectifier has to produce as well in that case. Yes, 337 volts exactly, because the capacitors are after the bridge rectifier. So then it goes to those transistors, and then because we don't have (167 volts minus). Okay, so as soon as we will have this capacitor replaced, we can plug it in and we can check what else is wrong. Again, this is not to play with. This is for trained people only. Yes, so whenever you've got power supply, don't learn it on your own, because you can get killed. You can get away with low voltage, but those big voltage thingies are really something to be scared of, and I'm not exaggerating. I even have some videos where I'm showing, and it, you know, electrocute me a bit. So that's it, that's end of the diagnosis. I don't see here anything. There will be probably something more, but before we won't replace the capacitor, that's it for this episode. Thank you guys for watching, and see you in the next one. Bye bye.